Okay, so this lecture is meant to introduce you to some of the wave behaviors that can occur, and the one that we're going to investigate the most is this idea of interference. And so definition of interference with waves is when two or more waves are at the same spot, same point in time. So when two or more waves occupy the same point at the same time, they're going to interfere. And they're going to interfere according to a principle called superposition. And so this is the idea that when two waves interfere, the resulting wave will be the sum of the displacements of the individual waves. So they're going to either add up or subtract depending on the directions of their amplitude. Okay? So with interference, you can have two different kind of categories of interference. One is constructive interference. And so constructive interference is going to be defined as when the waves that are interfering, when the waves that are interfering have their amplitudes in the same direction. Then the resultant amplitude combines to be larger. So, for example, if I have a wave pulse that I send in this direction, and I have another wave pulse that I send in the opposite direction, like coming towards each other, when they meet up in the middle, it's going to be a huge one. Like if this was an amplitude of 0.5, well, it's just easy, 1 and 1, then this one they have an amplitude of 2. And the thing to note, too, is after they interfere, they move along their merry little way. So this one would continue moving that way, and this one would continue moving that way, with their original amplitudes of 1. Okay? So the video is going to pause, and it's going to show you a little animation of that, and then we'll come back to notes. Okay, so this is going to show you constructive interference initially. What's going to happen is that there's going to be a wave pulse from the red wave that's going to go to the right. There's going to be a wave pulse on the blue wave going to go to the left, and this top one is going to just show you the individual red. This is going to show you the individual blue, and this is going to show you the summation of them. So we're going to see the superposition principle being applied in this. And there they begin to meet, they add up, and then they go on their merry way. So the next kind of interference you can have is destructive interference. That kind of got, I guess I should write it over again. So destructive interference is clearly the opposite. This is going to be interference. When the two waves that are interfering have their amplitudes in opposite directions, then their amplitudes will subtract to form a smaller waveform. Opposite directions. The waves will combine to form a wave with a smaller amplitude. So for example, let's say I send a wave pulse in that direction, and I send one in that direction. We have two coming at each other, both with the amplitude of 1. The result when they meet up will just be flat. The net amplitude will be 0, and then again, they'll move along their merry little way as if they had before they're interfering. Okay. So again, the video is going to pause, and it's going to show you an animation of this, and then we'll come back and do a little bit more notes.
Okay, so for this one, we're going to have destructive interference occurring. The red wave is again going to travel to the right, the blue wave is going to travel to the left, and we're going to see them interfere. And for this one, I'm going to pause it and kind of slow it down as they begin to interfere. So they meet, and right here they begin to interfere, and you can see this wave is starting to become smaller. This wave is going to start going smaller. And as I continue this simulation, right here, you can kind of see like this is where that blue wave is destructively interfering with that red one. And so that the red one essentially has like a divot in it. And then it kind of continues on. And I wish there was a faster way to do this. Right about here, they're no longer interfering with each other. They're just going on their own way.